All right, class, welcome to another math moment with Mr. Marcialis. Today we're talking about solving two-step equations. Our objective will be to solve equations in one variable that contain more than one operation. Let's move. Before we go into some examples, let's talk about vocabulary. So a few vocab words. Equation. What's an equation? An equation is like a math sentence that says one thing is equal to, the same as, or identical to another thing. And the key here is it uses an equal sign, okay? A variable. What's a variable? You'll hear this word a lot. A variable is a symbol, usually a letter, used to represent a quantity or number we do not know yet. We find out when we solve them, right? And then lastly, operation. An operation is a math process. And the most common that we know of, that we're familiar with, are addition, subtraction, multiplication, and division. Sorry, I moved myself to the upper corner here, and just stuff was getting in the way. So here we have a scale or a balance, which is kind of like what an equation is. It's as if we got an equal sign right there, okay? So it says 3 of these blue balls and 1 orange rectangle has the same weight, or is equal to, in weight, 7 orange rectangles. And so the question would be, well, how many rectangles does one blue ball equal to? Well, in order to do that, we need to get rid of this thing and get the blue ones, the blue circles by themselves. So we're going to take one orange rectangle away from each side in order to do that. And when we do that, the balance doesn't change. It stays equal. The scale is not going to tilt one way or the other. So then we're left with 3 blue balls on the left side of the scale. I didn't redraw the scale. And 3 orange rectangles on the right side. Okay? And so what we can do is we can see that each of these has a common factor. And so this means that for every one blue ball, it's going to equal 2 orange rectangles. There you go. So we have 1 blue ball equals 2 orange rectangles in weight. I use this illustration to show kind of that we need to maintain balance on the left and the right in order to figure out what one of our, in this case, blue balls will be our variable, what they equal to in weight as far as orange rectangles. So back down to the left corner of the screen here. So our first sample problem looks like this. 2x plus 1 equals 5. If we used our scale example from before, x could be our blue balls and how much do they weigh. And so here is the balance point. We have a left side and a right side. And in order to find out exactly how much 1x equals, I need to get it alone. So I'm adding 1 to it in the equation. In order to undo that, I'm going to subtract 1 from both sides. Remember, I need to do to both sides to maintain balance. When I do that, 2x, and there's nothing underneath it, so it comes straight down. Plus 1 minus 1 equals 0, so I just don't write anything. 5 minus 1 is 4. So this was our first operation that we had to undo. We had to undo addition, and so we used subtraction, okay? Lastly, we have multiplication going on between the 2 and the x, right? The x is our variable, it represents a quantity we don't know yet. And 2 is being multiplied to x, so I'm going to divide both sides by 2. In order to undo multiplication, I use the inverse operation, and that's division. 2 divided by 2 is 1, so I'm left with 1x, we just don't write the number 1, equals 4 divided by 2 is 2. Final answer. Example problem number 2, make sure you're putting these in the sample problem section of your notes. 3z minus 2 equals 7. So we got 2 operations here. We have multiplication going on between 3 and our variable z, and then we have subtraction right there as our other operation. So remember, it's like a scale. Whatever we do to the left side, we have to do the right side to maintain balance. And the first thing I'm going to do is I want to get this alone. So I'm going to eliminate the minus 2 by adding 2 to both sides. So 3z, 3 times z, comes right down. I have negative 2 plus 2, that equals 0, so I'm not going to write anything. 7 plus 2 is 9. Next thing we have to do is we have to undo the multiplication that's happening between 3 and z. We undo it by using division. And in this case, division is just like the fraction bar, which has its own name, by the way. This bar is called the vinculum. Either vinculum or viculum. Vinculum. It's vinculum. And if I'm wrong, at my email. Let me know or talk to me in class. 3 divided by 3 is 1, so I have 1z. We don't need to write the 1. When we write z by itself, it's implied that there's only one of them. Equals 9 divided by 3, which is 3. Final answer. Quick recap. Our objective was to solve equations in one variable that contain more than one operation. We did that. Remember, when you have an equation and you're trying to solve for the variable, remember the left side is the same as the right side. If you think back to our scale where we were weighing blue balls and orange rectangles, if we remove something from the scale, we have to remove the same amount to both sides so that the scale stays level. Just as if we needed to add something to both sides, we add the same amount to both sides so it's level. Okay, whatever you do to the left, you have to do to the right. You need to maintain balance in your equation. That way you can accurately solve for your variable. If you have any questions, you know how to get a hold of me. I will talk to you soon. Bye.